We are supposed to find out what the tangent of arc cosine of 1/2 equals to. This is really just the composition of two functions, of the inverse cosine function and the tangent function. So I will investigate this problem from the inside to the outside. I am first going to look at what is the cosine inverse or arc cosine of 1/2 going to be equal to. In order to find out which cosine value will produce 1/2, where this x has to be exactly between 0 and pi, as the cosine inverse function is only defined over this interval. In order to find out what value we are looking for, I can create my table for sine and cosine values. We are starting with small values from 0 to pi over 6 to pi over 4 to pi over 3, and as always we stop with pi over 2. Now the first function values that I'm going to write down is the sine of x. Sine of x. Sine is an increasing function starting at 0. Slowly but steady getting bigger. It is increasing. Cosine was doing the opposite. Cosine function is decreasing at first over the interval from 0 to pi over 2. And our values are just the same as the values for sine in reverse. Now, we are supposed to find the tangent of something, and that means I'm going to finish up my table here real quick, because if we wrote it in this way, the tangent function's output values are coming for free. Because tangent is the quotient of sine and cosine. 0 over 1 will give us 0. 1/2 divided by the square roots of 3 over 2 is 1 over the square roots of 3. Square roots of 2 over 2 divided by itself will give us 1. The square roots of 3 divided by 2 divided by 1/2 is just square roots of 3. And as always, tangent of pi over 2 does not exist. I am now looking really quickly. 1/2 is going to be produced by a value of pi over 3 in my cosine function. And that means that we had that x was equal to pi over 3. So in other words, I have right now that I am looking at tangent of pi over 3. Now pi over 3, my tangent function, will produce the output value of square roots of 3. And we are done.